All right, now some basic integration rules. So the inverse nature of integration and differentiation can be verified by substituting capital F prime for little f in the definition of indefinite integration and obtain the antiderivative of capital F prime equals capital F of x plus c. So integration is kind of like the inverse of differentiation, just like multiplication and division undo one another. Anti-differentiation undoes differentiation. Also, if the integral of f of x dx equals capital F of x plus c, then the derivative of the integral equals what you started with, okay? It's like if you add 2 and subtract 2, you still get the number you started with. So like if I started with 17 and I add 2 and subtract 2, you end up with 17. They cancel each other out kind of. So these two equations allow you to obtain integration formulas directly from differentiation formulas in this summary here. So since the derivative of a constant is 0, the integral of a constant, or excuse me, the integral of 0 is a constant. Since the derivative of k times x equals k, the antiderivative of k is kx plus c. Don't forget your plus c. Since you can factor out a constant when you multiply a constant times a function and you take the derivative, you just multiply the constant times the derivative of the function. You can do the same thing with integration. You can factor out the constant, take the antiderivative, and multiply the constant by the antiderivative. The derivative of a sum or a difference is equal to the sum or difference of the derivatives. Same thing with integration. When you anti-differentiate a sum or difference, the answer is equal to the sum or difference of the antiderivatives. The general power rule was when you took the derivative of x to the n, you brought the n down and subtracted 1 from it. Okay, so if you reverse that, instead, if you start with x to the n, you're going to add 1. Instead of multiplying by the exponent, you're going to divide by the new exponent. How I like to think of the general power rule for integration is you add 1 to the exponent and multiply by the reciprocal of the new exponent. Don't forget your plus c. All right, so let's describe the antiderivatives of 3x. So the integral of 3x dx equals 3 times the integral of x to the first power. You can think of it, since the exponent wasn't written there, you can write it as a 1. Also, the 3 can be factored out because it's a constant. The antiderivative of x to the first is you add 1 to the exponent and multiply by the reciprocal. So since the new exponent's 2, the reciprocal is a half, so it's really just x squared over 2 times that constant, so you get 3/2 x squared plus c. When indefinite integrals are evaluated, a strict application of the basic integration rules tends to produce complicated constants of integration. For instance, in example 2, you could have written the integral of 3x dx equals 3 times the integral of x dx, which is 3 times x squared over 2 plus c. The 3 is going to be factored outside of all that, and then you distribute it and you get 3 times c. However, because c represents any constant, 3 times c is still a constant. So what you do is, whenever you do an anti-differentiation, you just anti-differentiate the whole thing and then add a c on the end. Okay, I'll show you what I'm talking about. So 3/2 x squared plus 3c is written in a simpler form of just 3/2 x squared plus c. So note the general pattern of integration is you take the original integral, rewrite it, integrate it, and then simplify it. So let's talk about some of that. So if I have the integral of 1 over x cubed, just like with derivatives, okay, if it's not strictly x to a power, you can't apply the power rule. So let's rewrite this as x to the -3rd, the -3 power. Integrate, you add 1 to the exponent, so it becomes -2, and multiply by the reciprocal of the new one, then add your c, and you would get -1 over 2x squared plus c. This one, square root x, is the same as x to the half, so add 1 to the exponent. Now they divided by the new exponent, I would have just multiplied by 2/3. You get 2/3 x to the 3/2. The basic integration rules listed on page 400 in your book allow you to integrate any polynomial function, as in this example here. Now the integral of there's nothing there is equal to 1, okay? Which is equal to x plus c. Because there's nothing here, it's understood to have a 1 there. All right, and the antiderivative of 1 is x, so it's x plus c. This one you have integral of x plus 2. Then you could split them apart and do two. You can anti-differentiate each one separately. So you get 1/2 x squared. Now, technically, you would add a constant here, and the integral of 2 is 2x, add another constant. But really, if you add a constant and another constant, those two constants together make a constant. So really, you don't have to even do this step where you write two different constants. You could just slap a constant on at the end. Okay, so this one, you do each term separately and slap the constant on at the end. Remember, 3x to the fourth, you can think of it as 3 times the antiderivative of x to the fourth, which is x to the fifth over 5. Same thing with the minus 5x squared and with the x. And then you get that is your answer there. Okay? All right. So this one. Now, this is a quotient. Now, there was a quotient rule for derivatives. Antiderivatives, it's a little bit more difficult. There is no quotient rule per se for antiderivatives, and you do not just take the antiderivative of the numerator and denominator. Don't do that because it doesn't work. Okay, but lots of times you're going to be able to algebraically simplify the expression to get rid of the quotient. Same thing with the product. So let's look at that. Since it's divided by a common denominator of square root x, you can divide each term in the numerator by the square root of x and simplify that. Remember, square root of x is the 1/2 power, and when you divide like bases, you subtract the exponents. So that's how they got x to the half plus x to the negative half. Okay, and I would add that at this step, we have not done any calculus yet. It's just algebraically simplifying it. Then add 1 to the exponent and divide by the new exponent, and there's your answer. So remember, you can check your answer by differentiating. And this is what I brought up before. Integrating quotients, you can't just anti-differentiate the numerator and denominator there. All right, so that's it for some basic integration rules. Stay tuned for the next video.